So welcome to the Immersion community update. We've got a lot of things to cover. We'll be covering the upcoming tracks in a little bit more detail in this one. Welcome everyone. My name is Rolf Brink. I'm from Asperitas. I'm the Immersion project co-lead. And next to me, why don't you introduce yourself?
Yeah, John Bean with GRC, and I'm working with Rolf as a co-lead on Immersion and also co-lead on the materials compatibility. So we do have a fairly full session for you all this morning, and one of the first things that we'll be getting into for a deeper dive is the Immersion Requirements Revision 2. This has been an ongoing effort by a large body of industry authorities and subject matter experts, and it was really reflecting on that initial document, the Rev 1 requirements, and looking even at, as we published it, we knew then that we needed a follow-on to that because we realized that there were still some things that were not nailed down quite as clearly as they could be. And Rolf is going to be going through that and showing you the new structure and talking about some of the efforts that help to add clarity to what really is a requirement and maybe what is not a requirement, but for your information. And I'll let him go into more detail there. But I want to stress that there was an awful lot of effort by an awful lot of people, and he will definitely dive deeper there, but it's something well to pay attention to.
And following that session, it's going to be a material compatibility project update, which is, again, also one of the major topics. It's a separate project underneath Immersion. That is a project that is focused on the chemical stability of the fluids and the material compatibility related to immersion. As everybody knows by now, when immersing components, materials into fluids is accompanied with additional considerations for stability and reliability. There's been some significant effort going on also in a very large community, a very large group of experts and companies that have contributed a lot of materials which have been considered strictly confidential for many, many years. And the fact that these materials, the materials that are being published through OCP are extensive, and it sounds a new era for immersion cooling. And this project is led by Punit and John, and they will be sharing all the insights and the going-ons in that project during that session.
Then we're really fortunate to have a couple of good speakers coming our way from Asperitas and IT Renew. And they will be, one of the focuses will be on the IT Renew, and that's basically repurposing and giving new life to used assets and preparing them for an immersion environment. And I think that's going to be highly valuable to a lot of us because we realize as we go to a more sustainable future, we really need to make the most of what we've already produced. And looking at ways to get new life into some of those assets and re-leverage them in new ways is just really an important thing to consider because obviously these servers and the IT infrastructure, there's a fair amount of embedded carbon to make these things in the first place. And certainly trying to leverage that as much as we possibly can, as long as we can, and reuse applications is a wonderful thing. And then we're also going to be have the ability to get a presentation looking at a offer that is being made available on the OCP marketplace. This was actually one of the first of two offers that were evaluated against the original immersion requirements document. And that activity was kind of timely because it exposed, while we're still working on the Rev 2 document, it kind of exposed to us a few things that maybe we took for granted on that first requirements document because we found ourselves, even though we had the authors involved in the panel review, we found not quite sure what that was after all. So it was a very timely exercise to go through a couple of these panel sessions with authors to compare to it. And we're going to be seeing a presentation from Asperitas on this. So that'll be something to look forward to, and I think it'll be very enlightening for you what's been considered to make sure that it's a viable offer against some of the requirements that we've previously created.
So I'm going to try and speed it up again because I'm noticing that we're already running out of time. So after that, following that, it's going to be a panel session. It's an exciting one. Everybody here is probably aware of the announcements by Microsoft with the adoption of two-phase immersion cooling, which is exciting for this entire community. So Microsoft will be coming on stage together with the partners to showcase and share their experiences with two-phase immersion cooling in reality. They're going to be focusing on the lessons learned. A lot of important people, well-known people, established people in the industry who are going to be sharing a lot of their knowledge.
Yeah, and then to speed up as well, and thank you, Rolf, for the timing remark, we have Michael Sakamoto from UL. This is going to be very interesting. UL is now realizing that this industry needs some help from some standards to assess for true regulatory compliance. So Michael's going to be giving us a little bit deeper dive on this, and I really do think folks would want to pay attention to what he's going to share with us. It's going to be a great presentation.
But first, I'd like to invite on stage Raul from Submer. He's going to be presenting another community effort of a lot of the participants in the immersion community calls. They've prepared a pitch deck on what the value and benefit is of immersion cooling and why it's relevant. So Raul, please come up. He's going to do the lightning presentation of this, and it's good stuff. So
hi everybody. Good morning. Happy to be here. So let's talk about the evolution of the data center cooling. We started with and how, let's say, immersion cooling plays a big role on this evolution. So we started with legacy air-cooled solutions where we have in-row coolers, and we quickly, let's say, moved to backdoor heat exchangers and direct-to-chip. So these technologies actually have typically a low density by themselves. One of the things that actually enables immersion cooling is this integrated approach where we are able to dissipate over 150, 500 per rack. So types of immersion cooling. So we have mainly three types of immersion cooling. We can talk about single phase or two phase in several, let's say, formats. The idea behind single phase immersion cooling is that the liquid that we are using actually never change never evaporates, never change the phase, and we can find this over let's say horizontal systems, or we can discuss about, let's say, this approach, which is vertical rack immersion cooling. And then we have two-phase immersion cooling on a horizontal rack, where some of the players are actually leveraging this two-phase liquid that actually evaporates and condensates. So what are the data center challenges? So we're finding that we need sustainability, and I mean, there's a huge push on sustainability and decarbonization. We are seeing that with, let's say, a standard or legacy cooling systems, we have low capacity per rack, and we have water consumption and so on. So and we have, let's say, that push as well on the edge applications too. So how we can solve this with immersion cooling? It's kind of straightforward. So one of the things that immersion cooling enables is that we are going to use most of the time evaporative cooling or dry cooling most of the time. We are able to slash the TCO with innovative designs that cut, let's say, cuts the needs on UPSs and gensets. And actually, one of the great things is that we simplify the hardware and we simplify how those systems works, actually removing the fans and all of the moving parts. So it simplifies and it increases the lifetime of that hardware and the reliability. So it's and actually on the heat reuse propositions, we are able to actually connect those systems to heat reuse systems and extract from them high-grade temperature and enable this heat reuse. So how, focusing on the water consumption of this technology, one of the great things that we can do actually is to increase the working temperature of those liquids. And this actually allows us to simplify or to actually heavily cut the usage of evaporative cooling. So most of the time we see that we see a great reduction or a great slash on use of water. And then on the other hand, simplifying simplifying that hardware, we find that we are actually reducing the TCO and we are reducing the complexity of those systems, which allows for reduced CAPEX and OPEX all along. Well, let's discuss about the increasing energy costs that actually we are seeing. I mean, this is just a really great example of what can immersion cooling offer to the market, as we are actually simplifying the infrastructure required to run those systems. The POE or the efficiency on the system increases, and we are able to use less energy for the infrastructure overall. And then again, one of the great propositions, and I would say that this is one of the main ones, the high capacity per rack that immersion cooling enables, leveraging the way we dissipate the heat and the heat dissipation capacities that those systems are offering. We are able to increase the capacity per rack and then increase the density of the solutions overall, simplifying the HPC and other kind of applications. And the other hand is, as immersion cooling enables an environment, a thermal stable environment, I would say, one of the things that we get from this is not only this thermal stable environment, but a protective environment that it's actually fit for electronics. And then we are actually removing or simplifying all of the woes that most of the issues that we have with air cooling, like hotspots, zinc whiskers, and other kind of things that are critical for operation. And with that, we can simplify and increase the reliability of those IT loads. And we can discuss about data center safety again. As we are not using moving parts, we are greatly reducing the vibrations and other issues. And as well, humidity protection and fire safety are greatly simplified because we are actually using those systems in a protective environment, immersing those IT loads. And then we can discuss again.
Yeah, we're running out of time.
Yeah, I know. It's a really long presentation.
Yeah.
I'm trying to, let's say, highlight some of the topics. I know that I have to go fast. I don't want to spend some time. So one of the great things that we can do with immersion cooling is that as we can simplify and we don't need, let's say, this classic data center environment. It's really easy to go for and create edge solutions because they can be really compact. They can be actually solutions that can enable heat reuse, and they are easily deployable because we don't have any kind of noise, and they are fully modular.
All right. We're going to have to end this here. Sorry.
Yep.
But thank you very much for your effort here, and also.
Yeah. So these are available for download, so I'm not going to read off everybody's name, but we certainly had a number of contributors that helped out on this across the industry as a whole. So I definitely want to recommend everybody download this and take a look at it. And also, call to action. These links are available in the download as well. We would really love to get a lot more participation and people in the industry involved with us, because the shared experiences that everybody can bring to this really enhances our capabilities. And with that said, I'm going to serve it over to Rolf to go over the immersion requirements Rev 2. Rolf?
Thanks. I'll try and make up for some of the time. I'll swap out the presentations. So, immersion requirements revision 2. Let me start by taking you back in time. The original publication, the first immersion requirements document was published in May 2019. That took about 1.5 year work. And the main contributors of that were Spiritos, Intel, Schneider, Isotope, and Flex. A small group of participants. The immersion community was still relatively small at the time. But this laid the foundation of what we're doing today. And what we're doing today is actually a bit more exciting. Today we are at the verge of completing the second revision of this document, and this is a serious collaborative piece with, again, Asperitas and Intel, Schneider Electric, Isotope, but also Flex, TMG Core, Cargill, GRC, Vertiv, Shell, M&I Materials, and Submar. So what you're seeing here is actually a nice representation of some of the very active community members in the immersion community. We started this effort at the beginning of this year. So this time we took the original document, we analyzed the whole contents, and we decided to have a stab at generating a more structured document which would be more usable. And I'm actually quite proud to say that we anticipated taking about a year for this, and it looks like we're actually going to get it done before the end of the year. And this document is greatly expanded. So let me start with the purpose of immersion requirements. The whole purpose of the document is to, first of all, establish a common terminology. There's a lot of immersion technologies out there by now, but we want to make sure that at least when we're talking about immersion, we're using the same terms, we can use the same references, and we all understand what we're talking about. And we want to facilitate immersion-specific measures and with parameters of importance. So it means that we want to be able to focus on certain measurable parameters that specifically relate to immersion that everybody can use. And part of that immersion requirements document is an actual compliancy test, right? There's requirements in the document, which I'm going to come back to in a second, because that's probably one of the biggest things throughout this whole document, that there is explicit requirements that must be met before getting into the OCP domain. And part of that, the purpose of those requirements is to ensure that there is a minimum level of quality in that OCP domain as well. So when is this qualification necessary? The qualification is necessary to, if you want to submit an immersion solution spec. Let's say you've got an immersion tank that you want to submit to OCP as an open spec. Hey, this is one of the things that you need to test against. The OCP logo accreditation for immersion solutions. If you want to have something positioned, for example, on the marketplace as an integrated solution, you want to make sure that the immersion solution qualifies against this immersion requirement document. And there's probably more activities within OCP that are going to be require this kind of qualification. The qualification request, the qualification process is actually fairly straightforward. It goes through the project leads, and the project leads will be sharing a checklist, and that's a checklist that you can self-certify, that you can fill out, that you can test through whatever you have in-house, whether it's documentation, whether it's certain features that you comply with. And you can submit how you comply with these, or the fact that you do comply with it. And if that checklist is done, we'll invite you to present in the community calls, the monthly community calls, to get a 20 or 30-minute slot to make your presentation, to present your solution and how and why it qualifies. And then after that, there will be a panel interaction with industry specialists, with people from the community, your peers, who can interview you on whether you actually do qualify. And this is a process that we've now executed twice. We are in the process of refining it. We will be looking at refining this. So this is not set in stone, this process, but this is the intention behind the immersion requirement. So to start off with the actual requirements, we've now, one of the biggest revisions in this document is that we now split the actual requirements into 3 different categories. We got specification requirements, which need to be met by the immersion solution vendor, right? We've got operational requirements, which needs to be met in, optional requirements, which need to be met to get access to make certain claims about optional capabilities that you may have. You've got customer requirements, and these are things that an end user or a facility may need to meet. So in terms of a solution provider, you need to show that you're actually acknowledging that and that you are making an effort, that you're aware that you need to inform your end user or an operator that they need to work according to certain principles, for example. So the second chapter of the document is focused on technology definitions. Again, the common terminology. So we got TCS for the technology cooling system, facility water system, single versus two-phase enclosed chassis, open bath, hybrid. These are terms that are explained in this document. So touching upon this, I just want to clarify as well that this document, Immersion Requirements document, is actually a combination between an explicit list of requirements and white paper content. It's also very informative. It contains a lot of informative content. So not every chapter in that is dedicated to requiring things. A lot of the content in the document is there to explain the principles behind immersion cooling. And then we get into the first real requirements that are being stated. So chapter 3 is all focused on quality and safety. I'm not going into explicit requirements here. That's way too much. There is a whole bunch of requirements that are listed in the document, and this is something that there is a review version online. That you can find the links on the wiki, the Immersion wiki as well, so you can actually look at the current work in progress. But the first compliancy requirements are focused on certification. Make sure that whatever region you intend to sell this, that you comply with any regional requirements like UL, FCC, CE, you name it. And then you get to the safety. There is a whole bunch of safety requirements, things that you may not think about. So procedures that are related to immersion, usability by skilled IT personnel, but also think about electrical safety. One of these examples is, for example, bus bars. Everybody here knows about bus bars. You've got the OCP racks. They are equipped with bus bars on the rear end. You slide your server in, it connects to the power circuit, and bang, server is up. In immersion, that same bus bar could be at the bottom of a tank. Now, what happens if you're trying to screw something and you lose a screw? Okay, I know OCP equipment doesn't use many screws, but let's say you've got this small bracket that breaks off or drops down. What happens if that enters that bus bar? In a vertical rack, you don't have that problem because gravity doesn't work in that direction, right? But in immersion, it is. But these are dimensions that we need to be addressing with the immersion community, and we are, right? And for the rest, we're also talking about fluids and flumes and gas containment, and these are all requirements that can be found in these kind of paragraphs and chapters. And they're all expanded on, they're all explained, and they're all detailed. Then there is also facility-side liquid management. Hey, you're deploying immersion technology in a facility. Suddenly you got all these tanks full of fluid. So what do you need to do on a facility side to manage that, to work with that, to coordinate, to keep your facility safe, to keep it a healthy environment to work in? There's requirements specifying ventilation or things like, hey, you need to make sure that your fluid doesn't enter the sewage system, for example. Basic stuff that very often people overlook. Spill management. What happens if you got a catastrophic spill? Maybe at some point a tank falls over for whatever reason, right? It's not something that you anticipate, but hey, we're running data centers here. You have to anticipate the stuff. You have to get ready for the stuff that is very unlikely to happen. But there's also solution-side liquid management. Think about pressure release and two-phase systems. Compliance with volatile liquids. Maybe something that you might not think about instantaneously, but also evaporative losses. Fluids tend to evaporate at some point. So how are you going to deal with it? How do you contain that? There are solutions for all of this, right? And immersion vendors know their stuff or should know their stuff and should be addressing these things. Then it comes to immersion fluids. Now, this is one that I will not touch upon in too much detail because there's going to be an extensive presentation after this one focusing a lot on immersion fluids and material compatibility. But there is a lot of overlap with this document. All these work, all these efforts within immersion community are all connected to each other. Right? Earlier this year, or end last year, there was a white paper for IT optimization for immersion. There is a different project that was a spin-off of that focuses on material compatibility, and that also has its connections with the immersion requirements. So there's a lot of requirements that relate to the immersion fluids that will be detailed in the next presentation. And it also includes fluid quality management, I believe. And just looking at John here in the front row, that it does include fluid quality management, right? The next presentation, yeah. Okay. So then we get to the optional, some other optional requirements. There's feature classifications, right? So there's a minimum set of requirements that an immersion solution must have, and built upon those minimum requirements, there is additional features. In this case, we're referencing thermal optimized systems, we're talking about high safety systems, and we're talking about high availability systems, right? And this is like an onion. If you've got a high availability system, you must qualify with all the other optional qualifications, but if you have a high safety system and you want to be able to market it like that, you may not be able to meet the requirements for high availability, but at the very least, you must have the thermal optimization aspects, but always have the minimum requirements in place. The minimum requirements are really, truly very, very basic. It just addresses, hey, you need to have a measurement of your incoming and outgoing fluid temperatures for the dielectric side. You must have an overheat protection. You don't want to have a runaway effect with an overheating tank full of IT equipment that is worth millions, right? You don't want to risk that. You must have that thermal protection. If there is a pump, you need to have a pump status, at least, whether it's on or off, at the very least, and you need to be compliant with the redfish protocol, right? The redfish management tooling defined by OCP. Then the first optional requirement is thermal optimized. So let's say you've got a solution and you've put a bit more engineering into it. You are focusing on thermal optimization, whether it's for reuse purposes or just efficiency, doesn't matter. Hey, thermal optimization, it's not a very high bar to achieve. You need to have power monitoring in place. You need to have thermal monitoring of the facility water side interface, of water system interface. And it can also be done through the facility, but if you want to qualify as a solution for this, it needs to be integrated in the solution, or at least be available as part of the solution. You need to have some monitoring of the flow rate, and you need to have a controlled technology cooling circuit or variable pump, right? You need to be able to address that flow. Then you get to the high safety. And the first requirement for that one is that you're compliant with the thermal optimized solutions. Yeah? Before you can call yourself high safety, you must have control over that thermal aspect. Because, hey, everything we do is thermal. We're cooling stuff with fluid. So everything is thermal based. So you need to have control over that. And on top of that, you need to be able to report and log based on all the sensors that are equipped in the system. You need to have control over shut-off valves, right? If there is a problem, you need to be able to mitigate that problem. The system needs to be able to take action, whether that's fully automated or semi-automated, doesn't matter, but that action needs to be there. It needs to be possible. You need to have control over the electrical input in the system. Hey, don't forget, especially with immersion, every watt that goes in converts into heat inside that fluid. So as long as there's electrical power going in, there will be a buildup of heat, right? If there is a failure on the cooling system, you need to be able to control that power input at some point. It's great that you can monitor the thermal properties of the water circuit, but if you can't control that power input, you're going to have a problem. You need to have a fault reporting method. Yeah? You need to be able to alert the facility that a problem is underway or there may be a critical or non-critical error. That reporting must be in place, and automated safety responses and fault handling must be part of that solution. And finally, there is the high availability, which is stacked on top of that high safety again, which means that, hey, you need to have everything concurrently maintainable, right? This is not very different from what we're used to in the data centers, right? To be able to service these critical components without downtime. And then there's the general standards. Overall, these are still pretty much the same as the original document. So we're talking about classifying densities. You guys have probably all heard about statements and claims of immersion tanks, what it can do. Got an immersion tank, it can do 200 kilowatts in my tank. Great, first question, how big is that tank? Right, you got 100 U's, or is that 50 U, or is that 20 U? Because that actually says something. What is the actual surface area of that solution? How much floor space am I sacrificing with that solution? Because if your 200 kilowatts is going to take me the whole room, it may not be that impressive. It may not be that interesting. So we've been trying to normalize these density claims by adding a per square meter, and attaching that to degrees Celsius, right? 100 kilowatts at 10 degrees C as a cooling supply is a completely different solution than 100 kilowatts with 50 degrees C, right? So these figures are only meaningful if you can add per square meter at a certain temperature, right? So we're distinguishing between solution footprint, solution density, and compute density. So compute density indicates the physical space that the IT equipment takes up. That the tank, just with the bare tank that contains IT equipment without any additional add-ons onto the tank. Then you've got the solution density, which includes the full solution. So you've got a tank with cover plates, maybe some attachments to it, maybe some extremities, maybe you need some space before or behind it, just to facilitate a lid opening or to get access to a door. And then you have the actual solution footprint, which also includes the server space. So whatever you want to extract the server, you need to be standing in front of it. How much space do you need in that service area? So you have to factor that into the solution density. Right? And then you add to a certain temperature. So there is a reference to the temperatures that we require are harmonized with the ASHRAE figures for facility water temperatures. So ASHRAE W3, I believe from the top of my head it was 32 degrees C. That is one of the required references. And then finally we got the data center interface requirements. Right? So we require that there's differentiation between the in and output of every water interface. You don't want to be cross-connecting these, right? You know what? Apparently it happens a lot that engineers who run equipment, they just want to do a quick job of connecting that water circuit. The color coding really helps with an intuitive initial connection. And this is one of these topics where there's going to be further harmonization with the data center, with the advanced cooling facilities group, right? So this is one of these overlap areas where we're creating that harmonization further, where we're extending that harmonization further even. Right, but indicators with flow direction, color coding, and also material compatibility. You need to be aware. Let's say you've got an aluminum. Oh, but in the United States, what do you say here? Aluminum. I was getting confused. I'm Dutch. I'm not even native English. These materials can't always be connected to another material. So aluminum and stainless steel, for example, that you don't want to be messing with that. You need to be aware of the electrochemical potential difference of these type of materials, and this is something that that is already common with other liquid solutions as well in water infrastructures, and we're just making sure that these kind of things are documented and referred to. Then we get to the more informative side of the remainder of that document. So we covered pretty much all the requirements area, most of the requirements area, and there's a bit of white paper-ish content in that same immersion requirements document. That relates to, hey, uptime factors, immersion. Everybody keeps talking about how great immersion is, right? We're not talking just about efficiency. We're also talking about additional availability, additional uptime, features, if it's done well, right? Of course, that goes for everything. There's a description of what write-through means, write-through, right? What if the cooling infrastructure stops? You know what? Fluid has a very good heat capacity. You may be able to run a little bit longer without any cooling switch on. You may not need to switch off IT equipment within a minute or so. You might be able to run for another 20 minutes or maybe even an hour, depending on the type of technology and the type of implementation you're using, or whether it may have been designed to deal with that. So, seeing a typo here, thermal deficit. I think that's meant to say thermal design. How to design thermal design is covered, cooling infrastructure is covered, oxidation and moisture and IT compatibility. These are things that are covered in that immersion-related uptime area. And finally, to finish up that document, we've got a whole range of references. So a lot of this document is based on industry experience, technology that has been closed behind NDAs, just like with the material compatibility group, which is coming after this soon. But a lot of the content is now being published, it's being referred to, there's studies, there's references to existing materials, also other materials within OCP. So, I'm going to wrap this up, and I'm going to get off the stage. I think you guys have seen enough of me for now. I'm going to be handing over to John and Punit soon. First, before I do, I just want to point out, join and contribute in the immersion community. We're one of the most vibrant, most active communities, together alongside with advanced cooling facilities. There is a lot of exciting stuff happening in our community. There's a lot of good projects being kicked off, and we're really looking forward to welcoming all of you in our community call. Hey, and just want to say one last thing. I'm really excited to see physical people in front of me. That's so much more fun. Any questions?
Go ahead.
Siamak.
Great talk. Thank you very much for alerting us to sustainability. And your speeches in the past have motivated other people to jump and act. Just next door, there was conversation about modular hardware system, and based on the conversation we've had with this community on immersion cooling, now we see that's important for us to have immersion cooling in mind as we're developing modular hardware systems. And the white papers that the team is putting together hopefully will guide material compatibility issues to be resolved. And we invite the community to join and make the modular hardware system of tomorrow be sustainable.
Thank you. So there's an excellent addition as well. There's a lot of effort going into IT equipment development, and we're going to be crossing that boundary with immersion and server groups to make sure that whatever is being developed in OCP is going to be compatible with immersion, right? So, Don, I believe you're ready with somebody from who's joining the online conference.
Well, yeah, so there was a public comment from a Don Mitchell, and it said that the use of the clearance requirements would be a great concept to integrate with reference designs that ACF are trying to put out. So you actually would show what the footprint is and the clearance requirements, and that's one of the things we'll be talking about this afternoon. Just wanted to thank Don Mitchell for making those comments.
Well, thank you, Don Mitchell. Is there anybody else who would like to ask a question or provide comment?
So we have a couple of minutes.
Go for it, please. Please take your mask off so it doesn't come across.
Thanks for a great talk. My question is related to the requirements to be published. I'm just wondering if the environmental impact, such as greenhouse emission and things like that, for the coolants, would that be part of the requirements as well? Thanks.
Yes, they will be. Thank you very much for that question. Yes, they are, and I think the following presentation is going to follow up on exactly what exactly your question. So, please keep that in mind. And if your question doesn't get answered with the next session, feel free to get up to the mic again. Anybody else? Yes.
Hello, Rolf. Steve Harrington, Tildine. What is the requirement for the convection environment? Is there some kind of velocity requirement? And is there like an overall thermal resistance requirement?
Great question. No, there's not. We're leaving the internal workings of the immersion technologies, the solutions, to defenders themselves. So one of the things we're trying to steer away from is to overly standardize on topics that touch upon innovations that are still happening, right? So a lot of immersion technology is still in its infancies. There is a lot of innovation happening still. There's fluids that are being developed. There's advancements all over the place. And this is something that we're trying to make sure that we can facilitate, right? So we're trying to stay clear of the actual inner workings of an immersion solution, except for basic safety and monitoring and management features. Does that answer your question?
Yeah, it does. I would ask, does it make sense to have some kind of standards for people to submit, what they're delivering? Like they could say, if you optimize our system, it has this thermal resistance, and these are the standardized test methodologies that we recommend so that customers can compare them one-to-one.
Right, and that is, again, going into the next session. So please keep that question for after the next session. If your question isn't answered by the next session, you should walk up to the mic again. Yeah. I think we're running into, I'm not sure, is it break time, right? Yeah. So, it's time for a break. If you've got any more questions, I'm going to be here.
This is Joe Capes with Liquid Stack.
Hey, Joe.
Don, we've been listening to you, and we've been working with a third-party consultant, A&E firm, and GC, and we've done a pretty sophisticated model and a 36-megawatt hyperscale build that we should be able to contribute. So that'll have a lot of information on some of the spatial requirements and kind of a reference design that I think we can contribute to the
all right, that's fantastic. Well, let's keep that for the advanced cooling facility track this afternoon. But yeah, great stuff.